Hello, I'm Jennifer Ziegler, Vice President for Customer Success and Compliance at Grey. Our final program invites us to explore how nature can inspire solutions to vexing human problems. In biomimicry, which literally means copying from nature, the thinking goes that when approaching a new problem, why not look to Mother Nature, which has had billions of years to design a good solution? Next slide, please. Indeed, humans have been drawing design inspiration from nature for millennia. Consider how Leonardo da Vinci designed his flying machines based on his studies of bird wings. More recently, Frank Lloyd Wright advocated sticking close to nature in architectural design. In the 1950s, biophysicist Otto Schmidt studied squid nerves to develop a trigger that reduces noise in electrical circuits. And George de Mestral, a Swiss engineer and naturalist, became fascinated by the tenacious burrs that stuck to his dog's coat as they walked in the countryside. Eventually, he developed what we now know today as Velcro. In 1997, Janine Benyus published a book titled Biomimicry, Innovation Inspired by Nature, and formally named this long-standing practice of copying from nature to solve design challenges. Let's examine some more recent innovations that were inspired by solutions found in the natural world. Next slide. The lotus is a symbol of purity in some cultures for its ability to remain clean, even though it might grow in muddy water. Scientists discovered that the structure of the leaf is actually comprised of tiny pillars covered with a waxy substance. These properties cause water to bead on the surface and slide right off, taking dirt with it. Researchers at RMIT University in Australia developed a starch-based bioplastic imprinted with a similar pattern and coated with a protective silicon-based organic polymer. The resulting lotus-inspired material is a self-cleaning, sturdy, sustainable, and even compostable alternative to traditional plastics. When used for food packaging, for example, food waste could soon be composted together with the container it came in. Metal fabricators are also taking a cue from the lotus leaf. The European Tray Clean project uses high-powered lasers to etch microscopic spokes and ridges onto sheet metal. As with the lotus leaf, when water can only form in spherical droplets, it is shed rather than be allowed to spread on this fabricated metal. As a result, bacteria cannot stick to the surface. When used to make equipment for food service, for example, this antibacterial metal could reduce contamination risks and allow for less frequent cleaning and sanitizing with chemicals. Materials science have also developed a smart fabric that regulates temperature based on the way pine cone scales open and close in response to moisture. A pine cone has two layers of fibers that run in different directions. When the cone is separated from the tree and loses its water source, the fibers dry out, allowing the scales to open and pine cone seeds to be released. The inspired smart fabric uses two layers of materials with different responses to moisture. When the fabric absorbs moisture, such as perspiration, one layer expands more than the other, causing it to open and allow for better ventilation. After the moisture evaporates, the layer closes back up, thus allowing for better insulation. As inspired by the pine cone, this smart fabric can keep the wearer comfortable in changing conditions. Next slide. Our next biomimicry illustration echoes the climate change adaptation program that we featured in 2023. One California cement maker is mimicking how reefs are formed by coral to create a new kind of environmentally friendly cement. Underwater, coral uses calcium and magnesium to build its structures. Back on land, Calera is capturing flue gas emitted from power plants before it enters the atmosphere. They bubble the carbon dioxide through seawater to create calcium carbonate cement. This approach helps to reduce greenhouse gas emissions by sequestering carbon. However, by also producing cement, this innovative process turns the pollutant into a valuable building material, potentially mitigating the construction industry's environmental impact. And if the enduring ruins of ancient Rome are any example, these structures might also last longer. After all, the ancient Romans used seawater in their concrete mix, not the fresh water typically used today. Next slide. Not surprisingly, biomimicry is evident in the field of robotics, where humanoid robots can be trained to jump and flip. But for applications that require finer motor skills like grasping and sensing, roboticists are turning to the octopus, whose arms have remarkable flexibility, dexterity, extensibility, and strength. The European project, known by the acronym OCTOPUS, is developing a soft robotic arm with a structure that can bend in all directions, elongate, and vary in stiffness. In the US, Harvard's Tentacle Bot has a flexible tapered design, complete with suction cups that allows it to grip and manipulate objects. And researchers at the University of Turin are working on an octopus-inspired arm for surgery. Their robot's flexibility and ability to navigate narrow spaces makes it ideal for minimally invasive procedures. Let's go to the next slide. In our final example, biomimicry is improving automotive design. When German auto supplier Meul wanted to design a quieter, more efficient fan for electric vehicles, they turned to the owl, the notoriously silent hunter, for inspiration. Owl wings are covered with feathers that have comb-like serrations that smooth out air turbulence and reduce noise. Mayol created a fan with wavy blade edges like the feathers and added serrations all along the edges like the combs. Their owl-inspired fan channels and quiets the airflow and produces less than half the sound output of a standard automotive fan. Now, biomimicry is still an emerging domain, with two key organizations working to educate people about it and to help them learn how to apply biomimicry in their fields. According to their website, the Biomimicry Institute, based in Missoula, Montana, has engaged with almost 18,000 learners worldwide through various programs, including a 6-month practitioner certificate and education resources for teachers. The related Biomimicry 3.8, a certified B Corp, provides training and consultation to businesses to help them innovate bio-inspired products and designs. In academia, courses and programs around biomimicry are still very much in the forming stage, as Elaine mentioned earlier. While dedicated degrees are limited, we did find a few examples of universities that are leading the way. Let's go to the next slide. Arizona State University collaborates with Biomimicry 3.8 to offer graduate programs that focus on adapting strategies from nature to tackle sustainability challenges. Their joint Biomimicry Center offers a Master of Science and a graduate certificate with applications in design, life science, materials engineering, and business. According to the website, graduates apply their biomimetic knowledge in areas like transportation, product design, architecture, economics, and nonprofit ventures. At first glance, you might think biomimicry is relevant only for research universities, but we invite you to consider how the program could represent a niche for schools with a heavy emphasis on sustainability. To be clear, biomimicry could be a powerhouse when coupled with strengths in technology and engineering, but even schools with strengths in art and design could pursue a biomimetic niche. Here are some additional examples for inspiration. Next slide. The University of Akron leads with art and business in their description of an interdisciplinary biomimicry research and innovation center. In addition to incubating research projects and curricula, the BRIC hosts a graduate fellowship for doctoral students in collaboration with Great Lakes Biomimicry. The university also offers a 9-credit undergraduate certificate in biomimicry for students in any major. What might it mean in a major you are associated with for your students to, quote, seek inspiration from living systems to solve technical challenges, end quote. Let's go to our final slide. The Minneapolis College of Art and Design offers a 4-course biomimicry certificate that includes sustainable design and systems thinking. The certificate can also be embedded in a Master of Arts in Sustainable Design, guiding students to incorporate biomimicry principles into their design solutions. Just as nature continues to inspire creative solutions to human problems, We hope that you are similarly inspired by the biomimicry program idea for your college or university. This is particularly the case if your student has a commitment to sustainability, coupled with strengths in technology, engineering, art, design, business, or any combination of the above. Thank you.